Today we are going to look at the slope-intercept form of linear equations and practice finding the slope and y-intercept of a line from an equation. So let's get started. We can write linear equations in a lot of ways or forms. Here we have three linear equations. So y equal to negative 2x plus 7, y minus 5 equal to negative 2 times the quantity x minus 1, and 2x plus y equal to 7. Although the equations look different, all three represent the same line. We can use algebra to rewrite each of these into the other ones. For example, if we start with this middle one, we can use the distributive property to get rid of these parentheses. So now we have y minus 5 equal to negative 2x plus 2. And then we'll add 5 to both sides. We get y equal to negative 2x plus 7. And this is the first equation. Now from this first equation, if we add 2x to both sides, we end up with 2x plus y equal to 7. And that is our third equation. These equations are equivalent. They represent the same line, but are written in different forms. The first equation is in slope-intercept form. So y equal to mx plus b. So in this case, our m is negative 2, and b is 7. Now, slope-intercept may sound like an odd name, but it is called that because just by looking at the equation, you can determine the slope of the line and the y-intercept of the line. This second equation, well, that's in point-slope form. So just by looking at this equation, you can get the slope of the line and the coordinates of a point that is on the line. And then finally, there is standard form. ax plus by equal to c. Standard form is commonly used and quite useful, as we'll see in future lessons. But unfortunately, you cannot get any information just by looking at the equation. Notice we have a capital B in standard form and a lowercase b with slope-intercept. These are different. This lowercase b stands for the y-intercept. But in standard form, A, B, and C, these capital letters A, B, and C, all represent numbers, the coefficients of x and y, and a constant. Now, all three of these forms of linear equations can be useful, depending on what you're looking for or what you are trying to do. And we will talk about all three. But right now, we're going to focus on the slope-intercept form, y equal to mx plus b. Let's look at the line y equal to negative 2x plus 3. Let's graph this line by plotting some points. Well, let's set x equal to 0. When x is equal to 0, we have negative 2 times 0 plus 3. We get a y value of 3. So this is the ordered pair 0, 3. Well, wherever we have an x value of 0, that's going to be on the y-axis. So this is our y-intercept. Let's set x equal to 1. So now we have negative 2 times 1 plus 3. This gives us a value of 1. So we have the point 1, 1. So now we can set x equal to 2. So we have negative 2 times 2 plus 3 gives us negative 1. So we have the point 2, negative 1. Let's try a negative number. Let's try negative 1. So we have negative 2 times negative 1 plus 3 So you get 2 plus 3 is 5. And you have the point -1, 5. And we can connect these points to create our line. Now we already found our y-intercept. So when we're looking at the slope-intercept form, we have y equal to mx plus b. And this b right here is the y-intercept. The y-intercept is 3. Now let's look at slope. The slope is the rise over the run. So we can pick any point. I'll pick -1, 5. We start there, and we're going to go down to another point. We're going to go down 1, 2. So we went down -2. So we have a rise of -2. And then we went and ran +1. So we have a rise of -2, a run of 1, and that is -2. And our slope is -2. So for these problems, we're going to find the slope and the y-intercept for each linear equation, and then we're going to write that y-intercept as an ordered pair. So let's get these equations in slope-intercept form. So y equal to mx plus b. So we want a y by itself on one side with a coefficient of 1. Again, you don't need to show that coefficient. But if you do not see a coefficient in front of a variable, the coefficient is 1. And then that's equal to x times a number. That number is your slope, m, plus a constant. So this first equation, this is written in slope-intercept form. So our slope is equal to 1/3. That's the coefficient of x. And then b is the constant. In this case, our constant is -2. So our y-intercept is -2. Writing that as an ordered pair, we have 0, -2. The x-coordinate for the y-intercept is always 0. For this second equation, we have y equal to -x plus 4. This is in slope-intercept form. So you can't see a coefficient here. That means our coefficient is -1. So this is -1x. Our slope is equal to -1. And b, the y-intercept, is equal to 4. Writing that as an ordered pair, the x-coordinate is 0. The y-coordinate is 4. For this last equation, we have y equal to 7x. This is also in slope-intercept form. So where's our b? Well, this is just like y equal to 7x plus 0. So it's going to cross the y-axis at 0. So our slope is equal to 7. B is equal to 0. And as an ordered pair, again, x is 0. And now y is also 0. So this is the origin of the graph. We'll do the same thing with these three problems. Here we have 2x plus 3y equal to 9. Now this is not in slope-intercept form. This is in standard form. So first we're going to convert this to slope-intercept form. So slope-intercept form is y equal to mx plus b. So we got to get that y by itself on one side with a coefficient of 1. Everything else on the other side. So we'll subtract 2x first from both sides. Now we have 3y equal to -2x plus 9. And then we're going to divide both sides by 3. This gives us y equal to -2/3 x plus 3. So now we're in slope-intercept form. So our slope, is equal to negative 2/3. And then b, our y-intercept, is equal to 3. And writing that as an ordered pair, we get 0, 3. Next, we have y equal to negative 6. So again, this is y equal to, well, we have no x variable. So therefore, we have 0 times x minus 6. So if we don't have a variable, we can write it with a coefficient of 0. And that'll make that term disappear, giving us y equal to negative 6 as the equation. What that means is our line has a slope of 0 and a y-intercept of negative 6. In writing that as an ordered pair, we have 0, negative 6. Equations in this form, y equal to a number, that's a horizontal line that crosses the y-axis at that number. And finally, 3y minus 2 equal to 7x. This is not in slope-intercept form. We're going to use algebra operations to rewrite this in slope-intercept form. So we want to get the y by itself on one side with a coefficient of 1. So first we'll add 2 to both sides. We have 3y equal to 7x plus 2. And then dividing by 3, we end up with y equal to 7/3 x plus 2/3. So in this case, the coefficient in front of x, which is m, our m value, our slope, is 7/3. And b, that y-intercept, is equal to 2/3. And then writing that as an ordered pair, we have 0, 2/3. A great way to learn is to practice on your own. We will discuss in a bit, but go ahead and pause your screen and do these 4 problems. So when you're finding the slope and the y-intercept from a linear equation, the first thing you want to check is to see if it's in slope-intercept form. This y equal to mx plus b. So for y equal to 3/4 x minus 2, well, this is in slope-intercept form. The coefficient of x, which is our slope, is equal to 3/4. And the constant is negative 2. So our y-intercept, b, is negative 2. So as an ordered pair, that's 0, negative 2. For this second problem, we have y equal to 3 minus x. We can quickly rewrite this to put the x term first. So now we have y equal to negative 1x plus 3. You don't need to write that coefficient of negative 1. You could also just write this as negative x plus 3. Either way, that gives us a slope of negative 1 and a y-intercept of 3, which is 0, 3. Both of these equations are in standard form. So ax plus by equal to c. So one way to find the slope and the y-intercept of an equation in standard form is to first convert it to slope-intercept form. So for 5x minus 2y equal to 8, we can convert that to y equal to 5/2 x minus 4. So this gives us a slope of 5/2. And then the y-intercept is negative 4, or the ordered pair, 0, negative 4. And then with this last problem, we have 3x plus 6y equal to 16. This becomes y equal to negative 1/2 x plus 8/3. So our slope is negative 1/2. And the y-intercept is 8/3. Continue practicing finding the slope and y-intercept of linear equations, and I'll see you in the next video.